So welcome to a second video to support the month of November in the OCDSB scoping sequence for grade 7 and 8 students. This second block in November also focuses on strand B number, but specifically greatest common factor, lowest common multiple, and concepts around perfect square numbers. So for grade 7, now is the time to take a moment to talk about factors and multiples. This is also a good review for grade 8, but is not listed as a specific expectation for them in the new curriculum. A number can be written in terms of its factors. For example, the factors of 6 are 1, 2, 3, and 6. 1 is a factor for all numbers. Some numbers only have 1 and themselves as factors, and they are called prime numbers. So for example, 3 and 5 are prime numbers. So to determine the common factors among two or more numbers, factors are listed and then the common factors are identified, including the greatest one they have in common. So for example, as I just said, the factors of 6 are 1, 2, 3, and 6. The factors of 12 are 1, 2, 3, 4, 6, and 12. So the factors they have in common are 1, 2, 3, and 6. And the greatest common factor then is 6. Grade 6 students may be familiar with creating factor trees for composite numbers, so that is something you could draw upon as you start this learning. Knowing the greatest common factor among numbers can help with reducing the number of steps to simplify a fraction into its lowest terms. When doing this, the greatest common factor needs to be determined for both the numerator and the denominator. So this will be an important concept for students to grasp as they move forward in their learning. So the multiples of a number are the multiplication facts related to that number. For example, the multiplication facts for 2 are 2, 4, 6, 8, 10, 12, etc. To determine the lowest common multiple among two or more numbers, multiples are listed and then the common multiples are identified, including the lowest one they have in common. So for example, the multiples of 3 are 3, 6, 9, 12, etc. and they are all divisible by 3. The multiples of 4 are 4, 8, 12, 16, etc., and they are all divisible by 4. For 3 and 4 then, the common multiples are listed, and the lowest common multiple is 12. Knowing the lowest common multiple among numbers can help with creating equivalent fractions in order to add or subtract fractions with a common denominator. In this case, the lowest common multiple is determined for all the denominators. This is also a very important skill when thinking about proportional reasoning and solving problems that require proportional reasoning in order to write equivalent fractions. Both grade 7 and 8 will be working with perfect square numbers and square roots. Grade 7 will be working only with perfect squares, where grade 8s will be extending beyond just perfect square numbers. For grade 8, the specific expectation B2.2 are the math facts students need to know. They need to understand and recall commonly used square numbers and their square roots. This is something you can be working on all year. So here's a list of the perfect squares or square numbers. Any whole number multiplied by itself produces a square number, or a perfect square, and can be represented as a power with an exponent of 2. For example, 9 is a square number because 3 times 3 equals 9, or 3 squared. A perfect square can be represented as a square with an area equal to the value of the perfect square. Here we have a square with a side length 3 and an area of 9. The side length of a perfect square is the square root of its area. The square root of 9 is 3. It is important for students to understand the inverse or opposite of squaring a number is taking its square root. In grade 7, students should become familiar with the common perfect squares from 1 to 144 as listed on this slide. as well as their associated square roots. So how does this extend to grade 8? Each positive number has two possible square roots. For example, the square roots of 9 are positive 3 and negative 3, so we write this as plus and minus 3. This is because positive 3 times positive 3 is 9, but also negative 3 times negative 3 is 9. Although grade 8s have not yet worked with multiplying integers, you could extend to this idea at this point. Depending on the context, only the positive square root may be appropriate. For example, given the area of a square, the length of its side is determined by taking the square root of the area. Since the side length is a dimension, it makes sense to only determine the positive square root. So finally, grade 8 students also need to be able to estimate square roots. For example, if you ask students to estimate the square root of 60, they may first think about the perfect squares they know that are close to 60. So that would be 64 and 49. So that means the square root of 60 must be somewhere between 7 and 8, since the square root of 49 is 7 and the square root of 64 is 8. Since 60 is closer to 64, a good estimate for the square root of 60 would be something like 7.8. Developing flexibility with square roots and recognizing perfect squares will allow students to estimate more easily. So that brings us to the end of this video. I hope this was helpful, again, in planning your students' learning around greatest common factor, lowest common multiple, and perfect